Right, this review is on trigonometric inequalities. This is also a part of 3.10. Right, although they have given a unit circle, but I am not going to solve using this unit circle. And please be advised that even in exams, you will most likely may not get a unit circle. Anyway, whether you get or not, I think I have my own method and I'm going to tell you that you may like it. Let's find out. First, you need to know the graph of sine x, right? You need to know the graph of sine x. So between 0 and 2 pi, of course. So I know that the graph of sine x looks like this, right? I know that this is 1, this is -1, this is pi over 2, this is 3 pi over 2, and this is 2 pi. Now they need this value, so the sine theta, to be greater than root 3 over 2. And where is root 3 over 2, guys? It's somewhere over here, right? Root 3 over 2 is somewhere over here. So I want the red one, which is sine, to be greater than the green one, or equal to, which is root 3 over 2. So isn't my answer this portion of x? Now, all I need to find is what is this value of x and what is this value of x, which is pretty straightforward, right? Because when is sine root 3 over 2? Isn't that pi over 3 or 60 degrees? And when is sine another time root 3 over 2? Obviously in quadrant 2, right? Because sine is positive in quadrant 1 and quadrant 2. So in quadrant 2, we already learned that how to swing an angle in quadrant 2. It will be pi minus pi over 3, which is 2 pi over 3. So this point is 2 pi over 3. So my answer is just between these two intervals, and since equal to root 3 over 2 is also allowed, I will say that my answer is pi over 3 included to 2 pi over 3 also included. So that is the final answer. All right, so this is purely dependent on the graph. Likewise, here they're asking for cos theta. We need to know the graph of cos theta over here. So the cos theta looks something like this. This is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. The maximum value is 1, minimum value is -1. Okay. 1 over 2. Where is 1 over 2, guys? 1 over 2 is obviously somewhere over here. And I want this to be less than 1 over 2. I want red thing to be less than the blue thing, sorry, the green thing. So obviously till this point, the red is above green, right? So that's not allowed. I want red to be below the green. So it starts from here and all the way till this point. The red is below the green one. Okay, now when is cos 1 over 2? Cos is 1 over 2, obviously, when it's 60 degrees, so pi over 3. And another angle when it is 1 over 2 is in quadrant 4. And how to swing this in quadrant 4? By 2 pi minus pi over 3, which is 5 pi over 3. So this is 5 pi over 3 over here. Okay, so the answer is obviously right from here, this interval. So it starts from, and by the way, equal to 1 over 2 is not allowed. So we will not allow pi over 3 and 5 pi over 3 in our answers. So it will be like this. This is my answer. Likewise, over here, we have sine x as the function, and we need to find whether it is greater than or equal to negative root 2 over 2. Sine x looks something like this. 2 pi, pi, pi over 2, 1, -1, and 3 pi over 2. Negative root 2 over 2 lies somewhere over here. So that's the answer. And mind it, this time they need all the values. So we have to, oh, sorry, again, 0 to 2 pi, never mind. We need to find when is the red one greater than the green one. So obviously this portion, this entire portion, I'll just shade it. This entire portion is when the red one is above the green one. So I need to find this angle. When is sine negative root 2 over 2? So the reference angle is root 2 over, for root 2 over 2 is pi over 4. So I need to swing pi over 4 in quadrant 3 and quadrant 4. That's where sine is negative. So that will be pi plus pi over 4, which is 5 pi over 4, and 2 pi minus pi over 4, which is 7 pi over 4. So this is 5 pi over 4 and this is 7 pi over 4. So the answer is equal to values are also allowed. So it is from, if I want to write in interval notation, it will be 0 to 5 pi over 4 union 7 pi over 4 to 2 pi. I will include 2 pi as well because they are also including it. If I want to write this in inequality form, I will say 0 greater than equal to 0 and less than equal to 5 pi over 4, and also uh, greater than equal to 7 pi over 4 and less than equal to 2 pi. All right. Over here, they're asking when is fx less than gx. So what is fx? 3 plus 4 sine x should be less than gx. Gx is 1. I'm going to subtract 1 both the sides. So 2 plus 4 sine x should be less than 0. I'm going to subtract 2 both the sides. So actually, I should have subtracted 3 both the sides. But anyway, 4 sine x is less than minus 2. And then dividing both sides with 4, sine x is less than negative 2 over 4, which is negative 1 over 2. Once again, I'm going to make the graph of sine, which is something like this. Negative 1 over 2 is somewhere over here. And they want the red one to be less than the green one, right? So they are interested in this answer, of course. Okay. I need to find this value of angle. So when is it negative 1 over 2? It is 1 over 2 when it is pi over 6. So it's quadrant 3 and quadrant 4 angle because sine is negative in quadrant 3 and quadrant 4. So quadrant 3 angle will be pi plus pi over 6, which is 7 pi over 6. And quadrant 4 angle is 2 pi minus pi over 6, which is 11 pi over 6. So this is 7 pi over 6 and this is 11 pi over 6. All right, so that's our answer, right? And they want from 0 to 2 pi. So our answer is x is and less than. So less than equal to is not allowed. So I will make greater than 7 pi over 6, not greater than equal to. And less than 11 pi over 6. That's the answer. Okay. The next one is hx is less than equal to kx. So hx is 3 cos x is less than equal to kx, which is 1 plus 5 cos x. Subtracting 5 cos x both the sides. So I will have 3 minus 5 is minus 2. Minus 2 cos x is less than equal to 1. Dividing both sides with negative 2. But keep in mind that whenever we divide by a negative in an inequality, the sign flips. So cos x is greater than equal to 1 over negative 2. Now, the graph of cos x looks something like this, and negative 1 over 2 is somewhere over here. And I want the cos, which is the red one, should be greater than negative 1 over 2, which is the green one. So it is greater, obviously, in this region. Okay, we need to figure out these values. So it cos is negative in quadrant 2 and 3. And the reference angle for 1 over 2 is, I think, pi over 3. So the quadrant 2 angle of pi over 3 will be pi minus pi over 3, and our quadrant 3 angle will be pi plus pi over 3, which is 2 pi over 3 and 4 pi over 3. So this is 2 pi over 3 and this is 4 pi over 3. So the value of x, and equal to is also allowed. So the value of x in the interval notation will be, and we have to answer from 0 to 2 pi both included. So 0 to 2 pi over 3 union 4 pi over 3 to 2 pi. That's where it ends. Okay. Next one. Okay, this is a slightly different variety where we are given two, product of two expressions, and later on we have again some interesting questions. So let's try question number 6 first. If the product of two quantities is negative, then I think there are two possibilities. Either this is positive and this is negative, so that the product is negative, or this is negative and this is positive simultaneously, then also the product is negative, right? So let's do both these conditions separately. Okay. The first condition is I want 2 cos theta minus 1 to be positive. I'm not saying greater than equal to 0 because 0 is not allowed. And at the same time, sine theta plus 1 should be negative. I don't even think we need to. Okay, you will understand eventually that we don't actually need to do both all the work twice. Uh, so this is 2 cos theta is greater than 1 or cos theta is greater than 1 over 2. That's what we want. And here sine theta should be less than minus 1. Okay, interesting. I mean, can sine theta actually be ever less than minus 1? See, that's pretty interesting. I don't think so. Because we just learned that sine theta curve is like this and its minimum value is minus 1. How can it go less than minus 1? That's just not possible. So this condition is actually not possible. So there is no solution from here. So the other condition that we have is when 2 cos theta minus 1 should be less than 0 and sine theta plus 1 should be greater than 0, which means that sine theta is greater than minus 1. And yes, sine theta is always greater than minus 1. Just minus 1 is not allowed. So 3 pi over 2 is not allowed because at 3 pi over 2 it is minus 1, which is not allowed. But other than that, from 0 to 2 pi, it is always greater than minus 1. So I will say that from here my answer will be x is greater than equal to 0 and less than 3 pi over 2, and then 3 greater than 3 pi over 2 and less than equal to 2 pi. In other words, 3 pi over 2 is not allowed. And over here I need to do cos theta, the same arrangement as I've done here except the opposite sign. So cos theta is less than 1 over 2. Cos theta looks something like this and 1 over 2 is somewhere over here. I want cos theta to be less than 1 over 2. So the blue one should be below the white one. So blue one should be below the white one, means it should be something like this, right? Okay, what is this angle? This angle is, I think, wherever cos is 1 over 2, which is pi over 3. And this angle will be the quadrant 4 angle. So 2 pi minus pi over 3 is 5 pi over 3. Okay, and so from here our answer is pi over 3 to 5 pi over 3. We want to make both of them happy because both should occur simultaneously. So we want to make this one happy and we want to make this one happy. So, and don't you think, I mean, this one is always happy except 3 pi over 2. And we do have a 3 pi over 2 somewhere over here, right? That should be excluded because remember, 3 pi over 2 is 270 and 5 pi over 3 is, of course, in quadrant 4. So 270 is in this, this interval. So we just have to exclude that in our answer. So our final answer will become x. There are two ways to write. I think I can write as x is an element of pi over 3 to 5 pi over 3 except 3 pi over 2. Either I can write like this, or I can say x is from pi over 3 to 3 pi over 2 and 3 pi over 2 to 5 pi over 3. So this is an inequality way of writing it, and the first one is the interval notation of writing it. Both are correct answers. I'll just highlight that. This is our final answer. All right. Okay. Likewise over here, the product of two entities is greater than equal to 0, which means that either both are positive or both are negative. But once again, I mean, how can this be negative? How can you make the square of any number negative? Obviously, sine is a real number, right? And a square of any real number is always positive. So the negative is not allowed. I will only allow that sine squared theta should be greater than equal to 0. And 2 cos theta minus root 2 should also be greater than equal to 0. But this has like all the solutions, right? Doesn't matter what theta you take, this is always either 0 or positive. So this has no restriction actually. This answer will be 0 to 2 pi. It will always be happy. For this one, we need to make some effort. So 2 cos theta is greater than equal to root 2. So cos theta is greater than equal to root 2 over 2. And For this, I need to make the graph. Let's make the graph over here. Cos theta looks something like this. Root 2 over 2 is somewhere over here. And cos theta is greater than equal to root 2 over 2. So greater than means the white one should be greater than the blue one. So that happens here. Okay, what is this angle? This is when it is root 2 over 2, which is pi over 4. And this is the quadrant 4 equivalent, which is 7 pi over 4. How I found 7 pi over 4? By 2 pi minus pi over 4. So whatever is our answer for this one, that is our final answer, because this is always happy. So my answer is x is an element of, and equal to 0 is also allowed. So it's totally fine. We will take the points where it is getting equal to 0 as well. So it's from 0 to pi over 4. Pi over 4 is allowed. Union 7 pi over 4 to 2 pi. That's also allowed. So although this is answer only to this one, but I hope you understand that this one is always happy, because this has all the throughout interval. This guy is happy. So even this interval will be okay for this one to hold. And hence this is the overall solution when both are positive. Okay. This is interesting because this is now a quadratic in terms of sine. So whenever that happens, you just assume sine theta to be another variable, let's say x. So if sine theta is x, so the sine square theta is x square. So the equation is going to look like 2x square minus x minus 1 is negative, which can be factorized, right? It can be written as 2x square minus 2x plus x minus 1 is negative. From here, 2x is taken out. I'm left with x minus 1. The other one is already x minus 1. Then I take x minus 1 as a common factor. I'm left with 2x plus 1 is less than 0. And I think if I want the product of the two be negative, if you remember, we used to make a number line. We find the roots of this first, which is negative 1 over 2 and 1. Then we put any test point over here to figure out what's the sign over here. So if you put maybe 100, it will be positive. Then likewise, this is negative. If you put 0, let's say, and this will be positive, let's say, if you put negative 1. I want only negative, so it means that x should be between negative 1 over 2 to 1. But what is x? X is sine theta. So I want sine theta to be and greater than negative 1 over 2. So once again, I make a graph of sine theta, which looks something like this. A negative 1 over 2 is somewhere over here. I want sine theta to be greater than negative 1 over 2. So obviously it should be above the green one. But 1 is not allowed. 1 is not allowed means this portion, this is not allowed. And this happens at pi over 2, of course. So that's fine. Exclude pi over we'll exclude pi over 2 from our answer. But this is our answer. Okay. When is sine negative 1 over 2? For that, I need to find when it is 1 over 2, which is at pi over 6. So I need to convert pi over 6 in quadrant 3, which is this, and quadrant 4, which is this. So 7 pi over 6 and 11 pi over 6. So 7 pi over 6, 11 pi over 6. So how do we write our final answer? Well, I just made some space. So the final answer will be, remember, we have to exclude pi over 2. And 0 is not allowed. Wherever it is 0, that's not allowed. So we'll start from equal to 0 just means that these points are not allowed, because that's where they both are equal. So it starts from 0. 0 should be allowed. And then we have to break at pi over 2, because pi over 2 is not allowed. Union pi over 2 to 7 pi over 6. 7 pi over 6 is not allowed. And then again union, 11 pi over 6 is not allowed, but 2 pi is definitely allowed. So this will be a closed parenthesis. So this is how we'll write our answer in the interval form. In the inequality form, it will look like x is greater than equal to 0 and less than pi over 2, comma, pi over 2 less than x less than 7 pi over 6, comma, 11 pi over 6 less than x less than equal to 2 pi. That's our answer. Right, another similar question where we need to factorize first. So I'm going to factorize cos theta out. So I'm left with 2 cos squared theta minus 1 should be greater than 0. I think this can be factorized further because that's a quadratic, right? So it will look a little weird when we factorize this, but it will kind of look like, in fact, why don't we use our strategy and convert this entire thing into x first, because that's a single trig, right? So let's say cos theta is x. So it will become 2x cubed minus x is greater than 0. So x times 2x square minus 1 is greater than 0. And don't you think this looks like a difference of perfect square? Can I write this as root 2x square minus 1 square? Because now it looks like a square minus b square, which is a minus b and a plus b. And now I can make a number line. I can make the roots, I can plot the roots here, which is negative 1 over root 2 from this one, 0 from this one, and 1 over root 2 from this one. Again, I put the test points, but I think all are linear, and the most right, if we put, let's say 100, 100 will make everything positive. And it will just alternate the signs. That's how the linear, if all the linear factors, all the factors are linear, you just find the most right thing and then switch the signs. I need positive. So the positive happens when x is greater than negative 1 over root 2 and less than 0. And it also happens when x is greater than 1 over root 2. Okay. What is x? Cos theta. So I want cos theta to be less than 0 is greater than negative 1 over 2, 1 over root 2. That's situation number 1. So let's graph this. Looks like this. Negative 1 over 2 looks something over here. And y equal to 0 looks something like this. It should be between these 2 points. The blue one should be between these 2 green things, which is obviously this one. Okay. What are the x values? This is obviously pi over 2 and this is 3 pi over 2. And y is negative 1 over root 2. So y is 1 over 2, as in cos is 1 over root 2, sorry. When it is pi over 4, so I need to switch pi over 4 in quadrant 2 and quadrant 3. So in quadrant 2, that will look like, let me just quickly make some space here. Okay. Pi over 2, when it is swinged in the quadrant 2 angle, it will look like pi minus pi over 4. And pi minus pi over 4 is 3 pi over 4. So this point is 3 pi over 4. And when it is swinged in quadrant 3, it will be pi plus pi over 4, which is 5 pi over 4. So, okay, so my first answer is, and remember that it's only greater than, not greater than equal to. In other words, this is like only less than and greater than, not equal to. So these terminal points are not allowed. So x is an element of pi over 2 to 3 pi over 4 union 5 pi over 4 to 3 pi over 2. That's the answer. All right. And for the last one, I mean, we have two solutions, right? So one is this solution and one is greater than 1 over root 2. So greater than 1 over root 2 will happen. Let me just draw the graph quickly over here. It will look something like this. Negative 1 over root 2 is somewhere over here. And I want x to be greater than 1 over root 2, which means that cos theta should be greater than 1 over root 2. So the blue one should be greater, right? If the blue one should be greater, I think the answer should be something like this, right? And when is it root 2? Root 2 obviously when pi over 4, and the quadrant 2 angle will be 2 pi minus pi over 4, which is 7 pi over 4. So the answer is 0 to pi over, 0 is included, of course. 0 to pi over 4 is not included. And then 7 pi over 4 to 2 pi, and 2 pi is definitely included. So this is also the answer, and this is also the answer. There are 4 sets, in other words, like 1, 2, 3, 4. All 4 are separately the answers, but let me sum up the answers so that there is no confusion. Let me clear all this stuff up. Okay, so write the final answer over here, which is x is an element of 0 to pi over 4 union pi over 2 to 3 pi over 4. So I have included this one and this one. Then union 5 pi over 4 to 3 pi over 2. Union 7 pi over 4 to 2 pi, closed parentheses or bracket. All right, so this is our final answer, clubbing all the solutions for this question. It was slightly interesting, maybe a little lengthy as well, but yeah, I hope you learned how to do this one. We do have one last question. This is also clear factorization, so we know that now we have to take sine theta as, let's say, x, so it becomes 2x squared plus 9x minus 5 is greater than equal to 0. I think it can be factored. 2x squared plus 10x minus x minus 5 should be greater than equal to 0. Taking 2x out and minus 1 out from here, I'm left with 2x minus 1x plus 5 is greater than equal to 0. I'm going to make a number line. This is minus 5. This is 1 over 2. If I put any number greater than 1 over 2, maybe 100, this will become positive. And then I just switch the signs. I need greater than equal to 0. It means that x should be greater than equal to minus 5, or x should be less than equal to 1 over 2. X is sine theta. Sine theta is greater than equal to negative. Sorry, it's not greater than equal to, it's less than equal to. My bad. Less than equal to negative 5, less than equal to minus 5. How can sine theta be less than equal to negative 5? That's not possible because its minimum value is negative 1. So no solution. And sine theta is less than equal to 1 over 2. That's possible. We'll graph this. The graph looks something like this. 1 over 2 looks somewhere over here. Y is equal to 1 over 2. I want the sine to be less than 1 over 2. So the green should be below the white one, which means that this one and this one. This is the answer from 0 to 2 pi. When is sine 1 over 2? Obviously, when it is pi over 6, and quadrant 2 is 5 pi over 6. So the answer is x is an element of 0 is allowed. And remember, equal to 1 over 2 is also allowed. So these are also the solutions. So 0 to pi over 6 union 5 pi over 6 to 2 pi. That's the entire solution for this particular question.